Hey guys, it's Mr. Walker here again. Welcome to another math lesson with Mr. Walker. Today we're going to be taking a look at how we can use the area method, area model, to help us to solve division problems. So yes, we can use the area model once again to help us out in math, okay? And today we're going to be taking a look at how we can use that and to help us not only divide, right? Not only help us to solve some division problems, but we're actually going to tie it back to the standard algorithm and kind of make some connections as to how the two work together, or like the similar steps that you take, even though you are using two different methods to do so. So as we get started in this lesson, you really don't need much, just something to write on, something to write with. But I want you to kind of review back in your mind if you need to, go in your Wayback Machine and think about what we've learned about area so far. Like, what does area mean? How do we find the area? Any of those things that you need to refresh your memory about what area is. Take a second now, put yourself in that Wayback Machine, think about area, what it means to you, because we're going to be using that knowledge today to gain more knowledge and gain a better understanding of how division works and how we can use strategies like we already know with area to help us solve these division problems. So think about that for a second. Let's do some reviewing. All right, the area of an object. What is the area of an object? Let's think about that real quick. So if I had a rectangle like so, okay, and it had the area of, well, let's start with the sides first. If I had, let's say this was 2 and this was 5, right? And the area would be my width times my length, 2 times 5, which would give me 10. So my area would be 10, whatever this is. If this was centimeters, right, this would be 10 centimeters squared, okay? Taking that same logic, I can apply things kind of this way too. If we had known that this was 10 centimeters squared as my area, and I knew that this side was 2, well, I could go, okay, well, 2 times what gives me 10? Oh, 2 times 5 gives me 10. So this has to be 5 centimeters by 2 centimeters, and there we go. We can kind of make sense of area this way. So how does this help us with division? Well, what we actually did right here to find that missing side, that is division, okay? So we're just kind of using division and multiplication like interchangeably, like kind of going back and forth, and that can help us when we're dividing these bigger numbers. It can help us to use an area method like this to help us to find our answers, okay? So that's what we're going to jump into. We're going to do a couple of examples. Just make sure you have something to write on, something to write with, and then let's get going. All right, so I have a division problem here of 48 divided by 4. 48 divided by 4. So if I wanted to use the area method to help me solve this problem, I'm going to think of things this way. I'm going to think of a giant rectangle here that has an area of 48, and one of my sides is 4. So I'm looking for this missing length right here. What is this? 4 times what is going to get me to 48? So it's kind of framing our thinking in a different way. The cool thing about area, though, is I can take that 48. If I don't know how many times 4 can go into 48, I don't know what I need to multiply 4 times to get to 48. I can take that 48 and I can break it down a little bit into smaller areas to help me figure out my answer. Okay? Here's what I mean. If I take this 48, I'm just going to redraw it down here a little bit. All right, I can break it into chunks, into sizable chunks that like I understand and can find the division or multiplication facts a little bit easier. For example, I could break this into a 40 and an 8. And the same thing, I'm still going to be dividing them by 4, but now I need to think about, okay, 4 times what will give me 40? Well, that's easy enough. 4 times 10 will give me 40. So I know that this distance is going to be 40. I'm sorry, it's going to be 10. 4 times 10 will give me 40. Then I can think about 8. Well, that's 2. 4 times 2 will give me 8. So there we go. So I have those two distances. Now if I add those two distances together, I will get 12, which means that this number here, all the way across, will be 12. Okay? Again, to kind of frame this in another sense, let's go back to our number bonds, what we know about number bonds. If I had the number 48, right, and I split it into a 40 and an 8, I could think of this as 40 divided by 4 which is 10. 8 divided by 4, which is 2, and 10 plus 2 would give me 12. So that's what that missing distance is going to be. That's what our quotient is going to be. The answer to our division problem is going to be 12. So that's kind of easy enough using that distributive property, kind of breaking things down, right? Decomposing that 48 into a 40 and an 8 to be able to do those kind of smaller division problems and then adding those up to get our final quotient, right? Let's take this a step further. Let's see if we can challenge ourselves a little bit. Let's start with that same problem again, okay, that 48 divided by 4. But instead of dividing it into a 40 and an 8, instead of dividing it into a 40 and an 8, is there a way that we could divide it into something else? Maybe like 2 20s and an 8. Could we do that? Show me what that would look like. I could divide this up into a 20, 20, and an 8. Altogether, it would still be 48, but then I could do some even smaller division problems to help me out. So 20 divided by 4, well, that's going to be 5. So I know this distance will be 5. Again, 20 divided by 4 would be 5, right? 5 times 4 is 20. And then 8 again, that's 2. And there we go. And if we add these up, 5 plus 5 is 10, plus 2 more is 12. So our answer is going to be 12. The same answer we had. We just kind of decomposed it. We just kind of broke down that area a little bit more, made it a little bit smaller, made it a little bit easier to handle. And again, we could represent that with a number bond if we wanted to say the number 48 here. And it was broken into a 20 and a 20 and an 8, and we basically did 20 divided by 4, 20 divided by 4, 8 divided by 4, and that's how we got our answers. We got those partial quotients and then added them up that way. Cool, right? Easy enough. Let's take a look at one more example. Let's jump up a little bit here and do something a little bit bigger. Maybe like 96 divided by 4, okay? So if we're thinking of this in terms of our area model here, right? We have 4. We have the area of 96. What is going to be the number we're going to multiply times 4 to get 96, right? Thinking kind of like in that backwards way there. What are we going to multiply by 4 to get to 96? So we got to figure out that. So I could break this number apart just like we did in the other ones, kind of spread some things out a little bit here. Think of some easier division problems that we could solve. And if we went by what we did in the last one, I could just do 90 and 6, right? And I could do that, but I don't know 4 times any number that would give me 90. That wouldn't work, right? Not that I can think of right offhand or anyway doing my mental math. But I do know 8. If I went 80, I know that 4 times 20 would give me 80. So I think I'm going to do 80 instead. So I'm going to split this into 80 and 16. So if I do that, this would be 20, because 4 times 20 would give me 80. And then this guy would be 4, because 4 times 4 would give me 16. And if I added those two guys together, that would give me 24, which means this would have to be 24. 4 times 24 would give me 96, okay? Again, you could use that number bond to kind of break things down. You could even go smaller if you wanted to, and you could have split this into a 40 and a 40 and a 16, so then each one of these would have been 10 and a 4, okay? So there's different ways that you could kind of break it up, but you want to think of numbers that that would make sense, that are easy to divide by in order to find your answer. Like 40 was a good one to divide by, 80 was good to divide by, 90, not so much. 4 doesn't go into 9 as well. I can't do 4 times something to get 9, so that's not going to work. So think about those numbers that will work and work it through that way. Okay, so how does this all connect with what we're doing with like the standard algorithm and moving forward? How is this going to help us to keep moving forward in what we're learning about division? Think about it this way. Think about the number 4. How many 10s can get us as close as we can to an area of 9 10s, right? That's kind of what we're starting out here, is the 9 10s. How close can we get to that 9 10s? Well, if we multiply that 4 times 2 tens, that will get us to 80. And that's about as close as we can get, right? If we went by 3 tens, that would give us 120. We would be way over, right? No good. But if we did it by 2 tens, that would give us to 80. So, did it by 2 tens. Those 2 tens, that gave us 8 tens. We could subtract that out. You have 1 10 and 6 ones left to go. So now I have basically 16 square units left to go with a width of 4. So how many 4s can I go to get to that 16? Do 4 of them, right? To give us 16. 4 of them to get 16. And we've gotten all the way there, right? We don't have anything left over. So that's how we can start to make that connection to our standard algorithm and this kind of standard way that we'll be solving division. But for now, we're just focusing kind of on that area model, okay, and being able to break numbers down, to be able to divide them by smaller chunks, and then add those chunks, those partial quotients together to be able to get your final answer. So hopefully this helps. As always, if you guys have any questions, comments, or concerns, please reach out and let me know. But practice this a little bit, get familiar with it, and then have some fun dividing, guys, all right? All right, thanks for watching, guys, and we'll talk to you soon.